Okay. All right, I'm gonna start going over it. I know you guys won't have a lot to talk about. So give me a second. Let me go over it, and then we'll talk about those details. If you have a question, you let me know. So I think a lot of people get confused about if you have a cusp. A lot of time you got a cusp in the f prime of x. What does that mean? Does that mean you have inflection point or not? So I'm gonna show you an example of this. So we're gonna come back to answer those questions right here. So this value right here is the cusp at an inflection point. So even a sharp turn. So we're gonna show you an example that is kind of true. So I'm gonna talk about this. I'm gonna show you this. This is a piecewise function of f of x equal to x squared and f of x equal to negative x squared when x is greater than 0, when x is less than 0. Now, if I take a derivative of both functions, the piecewise function, I'm going to get g of x equal to 2x, right? And g of x equal to negative 2x. Now, guess what? If I were to graph this is the original function. If I were to graph this here, I have a cusp. I have a sharp turn. But original functions still have the inflection points. Do you see that? So that to answer some of you guys' questions says, hey, is it possible to have a sharp turn in f prime of x and still have an inflection point on the original graph? Yes, it's not differentiable for the f prime of x, but it is going back to look at original function is still functional. Okay. Now derivative of that one, derivative of the next function is going to be a two horizontal line. One is at 2, and the other one is going to be at -2. So it's going to be two horizontal line derivative of that. So yeah, it's not differentiable at that particular point. But if you look at original function, you can have an inflection point. Did that answer your questions? I think Katie, I think a lot of people after school tutoring, they were asking the similar questions. They were not sure whether that should be included in the inflection point, but it can. So, and I don't think I ever to show you the tangent line, which is tangent line. It's very, very cool. So this is something I want to show you. It's a tangent line. Oops. Do you see the concavity change when I go to the zeros? Like when I have x-intercepts, you see that, okay, I'm going to tell you is concave down, up, down, up, down, up, like this. Do you see that? See the tangent line is above is concave down and change at the inflection point. The inflection point occur right here, and right here. And I basically just use an equation tangent line is y minus y1, which is y minus h of a. A is some type of a value, we don't know, equal to h prime of a times x minus a. That looks like y minus y1 equal to m times x minus x1. So I can change the function. I'm going to show you the function. Let's say cosecant of x graph. Oops, that's really bad. Undo. Undo. CSCX. So you look like this. It's kind of like a ninja warrior. People have trying to like hang out something, right? So you can see that concavity that above the tangent line is concave down, is tangent lines above, is concave up, the tangent lines below. Okay, so very see it very clearly. So there's something that I would like to show you. I didn't get to show you on previous class, which is very interesting. Now we're gonna go over the homework. So the first page that we did in class yesterday to kind of build in for that, to build into all the things, but make sure you have to be able to justify. Remember, on your exam, you have to be able to justify something. You have to be able to justify something. Your test is on Tuesday. I will give you a graph that you have to justify. Okay, you have to justify. And will tell you justify. In this case, they don't tell you to justify. Okay, so here is all the answer for the first one. You can check. So you can check the number line. So the way I do number line is I look at, are they above x-axis first? Are they below x-axis? Are they above x-axis? Are they below x-axis? And I build my number line based on that. 3, 1, 4, 5. And then I just plug in minus, plus, minus, plus. Then I can see where's my relative min is and what my relative max is. And for A, can endpoint be critical number? Of course. It's f prime of x is equal to 0 is a critical number. So it doesn't matter if it's endpoint, it still applies.
So -5 can be a critical number?
Yep. Which is, that's the case, is -5. Because it didn't say anything else. It didn't say that it's not like mean value theorem cannot be an endpoint, but critical number can be an endpoint. Because long as f prime x equal to 0, it's fine. So f prime x equal to 0 at x equal to -5, x equal to -3, x equal to 1, x equal to 4. Yeah. Yes. Make which graph? What? Oh, why is it so small? Oh, my bad. Because I'm streaming on the wrong thing. And wrong thing. There we go. Any questions so far? Any questions so far?
Oh, did you just include -5 and 5 on your double prime number line just for reference? Like,
Yeah.
Oh, okay.
For reference. I didn't do anything before that. I didn't do a sign before after that. I do it, you know.
So would you only like not include endpoints in like your answer if it's like asking for like mean value theorem and things like
Or
that?
it's asking for maximum, relative maximum, because relative maximum has to be increasing and decreasing, right?
Oh, okay.
So you cannot have on an endpoint. You can have absolute maximum, but you don't, because the endpoint could be a maximum value, so it doesn't have to be that way.
Okay.
Questions?
How do you find the double prime x number line?
Double prime x number line, good. So the double prime is like the function's going up, right? So -5 to -4. This is going up is positive. So I'm looking at slope. I'm looking at slope of f prime because that means double prime. Slope is prime. So if I look at the slope of f prime means f double prime. And this function is gonna go down. So this is all go down from -4 to -1 is negative. And go up is positive. Go down is negative. Did I answer your question? Okay. Now some people write down like parentheses 3 and 4. Don't do that. It's much better to write this way so they don't confuse as a coordinate. People who grading it, it's not. But you can say like if it's a set number, if a set is gonna be a brace 3 comma 4, that's a set of 3 and 4, two values, but it's not a parenthesis or bracket. so they don't get confused with interval notation and stuff like that. But I would prefer to write this way, just a much better way to do it. And the way to write it is x is something like this, and the element of 3 and 4. So, but I don't prefer to write set because I'm not experienced at those. So now you have to justify f prime x on the test on Tuesday. You have to say f prime x changing from positive to negative, and that's how you justify something. At what x value does f of x has relative min? This one's min, obviously, because first is max, second is min. So at x equal to 1. Because you look at here, x equal to 1, there's only one went to decreasing to increasing, which is x equal to 1. Also, sorry, this one is f prime of x, not f double prime of x. So f prime of x changing from negative to positive. And increasing, I just follow number line. So once you have number line done, you just have to say -5, my bad, -5 to -3 and 1 to 4, because that's increasing. And you're gonna do a union. Union is like a U symbol. Okay, so usually you do union if this interval and this interval. And decreasing is going to be -3 to 1, union 4 to 5. Any questions so far? It's good. Inflection point is at x equal to -4. Because you see the sign change, you see the sign change, you see the sign change. It didn't matter if they are a sharp turn. It's not a problem. I think some people get kind of confused, and I understand where you come from. Even when I was teaching first couple year, I have some struggle with it as well. So it is normal to have that misunderstanding. But now I just show you an example. Hopefully that makes sense to you. That positive x squared and negative x squared. If you take a derivative of positive x squared, it's going to be 2x. If you take a derivative of negative x squared, it's going to be -2x. So it's going to form a cusp. And that's still inflection point on the original function. You saw it. Okay. Point inflection is x equal to -4, x equal to -1, x equal to 2. You do have to justify f double prime x changing sign, or you can just change it as f prime of x changing from increasing to decreasing or decreasing to increasing. That's probably a best way to do it. Just do f double prime of x changing sign, changing from positive to negative or negative to positive. That's better. And a concave up is going to be this. Concave down is going to be this. Any questions so far? If you know how to draw a number line, you're in good shape. It has no math involved. Like a lot of you guys are kind of like, this part is kind of, you can like kind of relax a little bit. There is no arithmetic, just analyzing. But sometimes analyzing could be harder for students, but we provide a systematic approach instead of just ask you to analyze. Some people can do it. Some people need tools. I personally prefer tool, but it's also because I'm teaching so many years, so I can tell right away. But some people are very intuitive; they can tell right away. It didn't matter. It just, I prefer have some type of systematic approach to this.
So on our test, we're gonna have like one of these.
Yeah, you're gonna. This is an AP exam question. Look at this. This is an AP exam question. And if you do number line test here, you should do a number line test. You should do a f prime of x. It's at -2. That's it. It's a positive and negative, right? F prime of x. And f double prime of x is going to be -1, 1, and 3. So it'll be negative. -1 to 1 is positive. 1 to 3 is negative and positive.
For the f prime number line, do you not include 4 as a value as well?
You can, I mean, but here it's gonna be, you can including 1 as well, it's gonna be 0. And 4, it doesn't matter, it's a 0, but the whole thing is gonna be negative. So if I want to be very, very picky, I can say that's negative, negative, 0 here. Had relative maximum at -2, right? That's it. 1 point. So easy. Easiest point you're gonna get all year. X equal to 1. Second point, you're gonna say f prime of x change from positive to negative. Second point, 2 points right here. Easy. You can do this all day. Now, on which open interval between -3 to 4 is f both concave down? So concave down is negative infinity to -1, but concave down and decreasing. So that you have to be careful. Yes. X equal to, oh, sorry, -2. I screwed up.
Not so easy point.
Not so easy. Yeah. I make a very common mistake what everybody usually makes. Thank you. And both concave down and decreasing. So what would that be? -2 to -1. Okay. -2 to -1. Union and 1 to 3. Yep. And find the x coordinate. So it'll be x equal to -1, x equal to 1, x equal to 3. And there we go. I answer all the points. How many points I can get here? It's giving a reason. It says f prime of x is less than 0 and f double prime of x is less than 0 as well. That's how your reason is. Because f prime of x is less than 0, f double prime of x is less than 0. So you will get 2 points here. And you will get 2 points here. So this is f double prime of x, changing sign. And that's it. You get 6 points. Wow. That's easy all day.
Do you want to use the graph instead of the number line?
I will use a number line to justify. I will use a number line to see the understanding, but some people can read a graph. I don't prefer read a graph. I can do it. Just now I make a mistake. You obviously see that. So I prefer to do the number line. It's just me. Now that number line doesn't mean justification. So okay, so find the relative extrema. So I hear after you did the number line on the first derivative, I believe the critical number is -1, 0, and 1, right?
Yeah.
I don't remember the sign is. Can you tell me the sign?
Negative, positive, positive.
Okay, so there is no minimum at 0, right? And there is a minimum here, maximum here, right? But how do you test with second derivative? I will test the same questions. I will say, can you show me? So what happens is you're gonna plug in a 0 here. If you plug in 0 on the second derivative, I don't know what the second derivative is. Okay, so I'll plug in 0 here. I will plug in 0, and you'll find out it's 0, so it's fail test. It's inconclusive. Therefore, it's not maximum and minimum in this case. You can tell on the first derivative it's true. Now, and positive 30 is concave up. So it's up, then therefore it's a max. Oh, no, it's a min, sorry. And we just verify this 100%. So I'm going to tell you second derivative is pretty accurate. 60 times 1 plus 30 times 1, that's equal to -30, is down, concave down, so therefore it's a max. So we verify with second derivative. I will show you, I will give you a similar question on the test. And you have to know how do I do it. Usually I'll give you f prime of x graph. That makes it easier because
What would it be basically? So like, what would be the circumstances where it's not possible? A second derivative test is not possible. Like right off the bat, how would you?
well, it's equal to 0, it's a failed test. Then you have to go back to the first derivative, look at the sign change. Because usually there's no sign change. So if it's something like positive and then positive like this, so for example, that graph I give it to you is negative x squared and x squared. Yeah, that's the test that you will fail because there's no maximum minimum. There's no justification there.
So if f prime of x doesn't have a maximum or a minimum, then you automatically can't do the second derivative test. Like it's not possible.
If there's no critical number, let's say f prime x equal to 0, then therefore you don't need to do the test at all, because if a function just keep on increasing, there was a maximum minimum. It's a function like this, just keep on going up, there's no maximum minimum.
And then if your f double prime of 0 doesn't fail, you stop at that, or do you also have to plug in your other value?
You plug in all the critical value to see are they positive sign or negative sign. The positive sign is concave up, just like this, so it's a minimum. If there's like this, it's a maximum. Okay, so this question is great because this is the first time I'm asking you to graph it, especially part E, right? So I'm just gonna do a very fast thing, decreasing. Hopefully I don't make mistake like last time, which is decreasing is gonna be from 0 to 1, union from 6 to 8, and justify decreasing. This one is gonna be f prime of x is less than 0, and that's how you do it justify, because f prime of x is less than 0. What x value has relative max? So max is going to be x equal to 6. That's going to be a maximum. And x equal to 1 and x equal to 6 is going to be a minimum. And then because f prime 8, 1 and 6, or 1 and 8, you're right. 1 and 8, it's going to be a minimum. Thank you. F prime of x changing from positive to negative. And this one is f prime of x changing from negative to positive. Concave up is going to be, I believe, 0 to 2, 3 to 5, and then 7 to 9. Union. Justify because f double prime of x is greater than 0, and that's how you justify. Am I doing okay? Did I make a mistake? Inflection point is x equal to 2, x equal to 3, x equal to what? 5, and then x equal to 7. That's a lot of stuff. Now I will do a number line test because it will make things easier for me to sketch this graph. So at this graph, I'm gonna graph like, I'm gonna do a number line. So I'm gonna do f prime of x first, which is, I'm gonna start at 0, right? And 0 to 1 is gonna be negative, and 1 to 6 all the way here is gonna be positive, and 7 is gonna be what? No, 8 is gonna be negative and then positive. And f double prime of x is equal to what? Well, it's gonna be at 2 and at 3 and 5 before 6, okay? And 7 is right between here, 7. So it's gonna be positive, negative, positive, negative, and positive. Okay, so now we're gonna use all the information to sketch in the graph. So you have to make sure you use this. So I'm gonna graph in. First of all, I'm gonna have a 0, 0 because this is the what f of 0. They what test you that, which is 0, 0. Are we okay? When you go to 1, so the 1 is a minimum, right? And this one is a maximum, and this one is a minimum, right? Are we okay here? So at 1, you are gonna get some type of decreasing, and at 6, you're gonna go to a maximum. At 7, you're gonna come back to minimum, and then go back to increasing. So basically, I will sketch in like some type of things that tells me that. So I sketch in as a dotted line for the first derivative. So a dotted line is gonna give you something like this, right? And after 1 is gonna be 1 to 6 is gonna go positive, right? Positive like this, and negative, and then positive like this, maybe. So I don't know the concavity. That's why I draw the dotted line. I'm not for sure with the solid line yet. So are we okay here? So now what happened is I'm gonna graph in. Um, oh, here I'm gonna be careful with this part. Okay, so I'm careful with that part. I'm just gonna talk about that part in a second. So I'm gonna have a concave. I'm gonna draw all the inflection point. Inflection point is at 2, 3, 5, and 7. So at 2, which is roughly here 2, I'm gonna draw inflection point, which is the black inflection point right here. And at 3, there was an inflection point right here. And at 5, there was an inflection point here. And at 7, there was a wait, 7, something wrong with that part. Oh, this is 8, so 7 is fine. Oh, so I see there's a graph something off here. This go into 8. This is going to 8. So it's decreasing all the way to 8. And after 8, it's going to go up, right? So therefore, it's going to be 2, 3 at cross. The cross is IP, inflection point. Every time I draw a cross is IP, IP. And at 7, there was IP. Are we okay here? I put in 4 crosses on the dotted line.
Wait, why would at 7 there be a cross?
Because at 7, there was an inflection point. 2, 3, 5, 7. So now I'm going to sketch this graph. Now I'm going to sketch it with the highlighter first. So it's going to be like this. Oh, also, hold on. Also, I'm going to sketch in the minimum here. Minimum happened at 1, so I'm going to draw a smile face right here. And at 6, there was a sad face here. And there was a happy face right here. Do you see that? A minimum, maximum, minimum. Are we okay? Now I'm gonna draw in everything else. So it's gonna be here. It's concave up, right? Concave down. Do you see that concave down? Concave, sorry, let me do it again. Concave up, concave down, concave up. Because every time I go to the cross, I have to change. Concave down and concave up. So basically, this graph is. So I'm gonna draw it with the red line. So it's gonna be concave up, concave down, concave up, concave down, and concave up.
The earned points on like an FRQ, what are like some of the basic components that you should include to like make your graph get the most points, I guess? Like should you include points of
Well, the good thing is they don't test curve sketching anymore. So because the rubric of this is kind of hard to analyze, every graph is going to be different. So rubric is really hard to determine. In 1980s, 1990s, beginning of 1990s, they kind of changed everything. At end of 1990, they say this is too hard to grade. And besides, students have graphing calculator already, so they can actually using graphing calculator to do it. Now, for me, is to understand the concept. How is those reflect to each other? I will test you, but AP exam will not test you curve sketching. It will be on the test. You will have one question on this, and you have to figure out.
And then what? So you want on your test, you want the inflection points like with X's and stuff like that.
Mhm.
You want us to identify inflection, and
Yeah.
you want us to like say where it's concave up and then concave down.
Mm-hmm.
I don't know, let's check it.
Mhm.
Is the velocity stuff that you're doing before, is that gonna be in the test?
Velocity? No, because we're gonna come back to talk about velocity again, but with a calculator this time. So that's why you need to have a calculator next week. Okay. So how much time I have? Okay, good. I have this original functions here. It's f of x equal to x times x minus 3 to the third power. I want you to take a first derivative, and I want you to take a second derivative. And if you can, I want to do number line tests. So first, original function, I need you to look for the x-intercept. And then I'm going to ask you to do f prime of x with the number line. So double check everybody's f prime of x, factor out GCF. And also double check each other with f double prime of x, check with each other, make sure they understand. Make sure you factor out GCF. And then because if you see a factor, it's much easier to do number lines tests rather than everything that's mixed together.
It's x times x minus 1 to the third.
Check each other with the f prime of x, just make sure they take derivative correctly, factor out GCF, and then do a double prime. But the first original function, can you look for x-intercept? It's really easy. There's two values. There's an x-intercept there. Right off the bat, you should be able to see it. Each factor equal to 0 is going to give you x-intercept.
Can you do chain rule for this?
You have to do chain rule and product rule. You cannot do it without it. Just because anything to other power than 1 usually has something to do with chain rule. The only time you don't have the chain rule is x minus 4 itself.
Two plus 1. Yeah. Very, very close. There has to be a plus sign for change. It should be 4. Could you take the square? Please, how did you do this? Yep, you have to do the square. Yep, and that's perfect. And I just take that around the
I'm going to see the x-intercept is occur at x equal to 0 and x equal to 4. Hopefully you see that right away out of bat. you will have a 0, 0, and then 4, 0 is your x-intercept. There is no 1. If you plug in 1, it's not equal to 0. You just take each factor and you set it equal to 0. So x equal to 0, x minus 4 equal to 0.
Wait, what was the first derivative then?
The first derivative, I'm going to give it to you. The first derivative is going to be 4 times x minus 1, x minus 4 square. I think you're looking for this one.
Yeah.
No, x-intercept from the original function. Because you have to graph that first. And if you do your second derivative correctly, you should get 12 times x minus 4 times x minus 2. Does that make sense? Then I'm going to do a number line test. A number line test at 1 and 4th. So at x minus 1, x minus 4 square. Nicholas, please don't pack things up. You're the last one to arrive and you're the first person to pack things up. Okay, so positive, 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 and then this one's negative, positive, positive. So it's decreasing, increasing, increasing. And here, I will draw it as at 2 and 4th, and that's going to be a positive, negative, positive if I end up with an x minus 4, x minus 2. Now I will go in to graph the rest of them. If I can make this video, I will remake this video again. Just make sure I go